So here we have another system, right? Here's the system, and this time we have a line. That's a line, and we should be aware of that. And this one down here is a circle. So we did study circles, so um, you should recognize that in the standard form of a circle. At the end, I'm going to show you visually what it looks like. Now, you don't have to graph these. You can solve these without graphing them. I just like to show the picture because I think it helps to see what's going on. The book, they don't necessarily do that. And the next problem, I think, I'll show you what the graph is, but we're not as familiar with the graphing. Okay. Anyway, how to solve this? They tell us to solve by substitution. Okay, so you're looking for an equation that you could get either x or y by itself. Well, the top equation, that linear equation, is going to be the easiest one. Probably easiest to get x by itself. And so we're going to add the y over and say x equals y plus 3. Then that we can substitute into the other equation. Remember, you have to go to the other equation. So we're going to have y plus 3 minus 2, and then we're going to square that, plus y plus 3 squared equals 4. Now it's all in one variable. So let's try to make things a little bit easier here. And you might think, oh, there's going to be something special. Where did that 1 come from? It was the 3 minus 2. Okay, but no, we're just going to have to multiply these out. So squaring a binomial, y squared plus 2y plus 1, that's what you get there, plus y squared plus 6y plus 9 equals 4. Okay, now gathering like terms, 2y squared, let's see, 8y plus 10 equals 4. I can subtract the 4, so 2y squared plus 8y plus 6 equals 0. I think I'll go ahead and divide everything by 2 to make my numbers smaller. I'm allowed to divide both sides by 2. So I don't get any fractions. So I say, hey, this is okay with me. All right. And then I get y plus 3, that's factors, and y plus 1. So it looks like we're getting two solutions for y. Y is negative 3 and negative 1. Now, how do we find x? We have to go back to that substituting equation right here. So I'll bring it down a little bit. X equals y plus 3. Okay, but what's y? Well, we said y could be negative 3. And in that case, x equals 0. So we're expecting one solution to be 0, comma, negative 3. Remember, you're going to write an ordered pair x, comma, y. Now, the other solution, x equals y plus 3, but we're going to say x equals negative 1 plus 3, or x equals 2. So our other point that we think is 2, comma, negative 1. Now, you don't always get two solutions. Sometimes you get more, sometimes you might get less, but that's what we think is happening. That we're going to feel pretty confident that those are the answers. We've solved it algebraically. Now let's get a picture of what's going on. We know how to graph this equation up here. It's linear, right? Okay, so if I do some switching around, I could have x minus 3 equals y. So I know it goes through negative 3, 1, 2, 3 down there, and it has a slope of 1. So I know the line goes something like that. And then this circle here. So good chance to review how to graph a circle. I'll put it in a different color. We'll see if that helps. But the circle is centered at 2, comma, negative 3. So let's go to 2, negative 3. There's the center. And then the radius is going to be the square root of 4, which is 2. So I'll count 2 in each direction. And so there's the circle, kind of. Okay. But you can kind of see those points of intersection, right? One right there, which that looks like 2, negative 1. Oh, yeah, that's one of our answers. And the other point of intersection is right there, which was 0, 3. I'm sorry, 0, negative 3. Yep. So that's a picture of what's going on. Again, you're looking for points that they share in common. This time it's a circle, and the line goes through the circle in two places. Now, that doesn't happen with all circles and lines, but it did for this system. We'll see another system in the next example.